Hello students and good morning. So now I am doing class for class 11. So this is the continuation class. So in the last online class also we were doing the same topic, trigonometrical ratios of associated angles. Today we will continue this chapter, that is trigonometrical ratios of associated angles. That is same exercise 3, 4 marks section, and it is page number 124. So in the last online class we did question number 3. So today we are doing this question number 4. So the question number 4 is you have to find out the sum up to n terms of the following series. The series given here is sine theta plus sine of pi plus theta plus sine of 2 pi plus theta plus sine of 3 pi plus theta plus dot 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 to n terms. Okay, the last online class में हामीले question number 3 सम्म गरेका थियौं. So I hope तिमीहरु सबैले नै question number 3 सम्म राम्रो बुझेका छौ होला. त घरमा रिभिजन गरि नै रहनु. त आज म तिमीलाई यो question number 4 देखि स्टार्ट गर्दै छु. You have to find out the sum up to n terms of the series. Here the series is given as sine theta plus sine pi plus theta plus sine 2 pi plus theta plus sine 3 pi plus theta plus dot 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 to n terms. So here n terms is given. It may be 2 terms, it may be 3 terms, it may be 4 terms, 5, 6 and so on. This is generalized. Okay. So here the n terms, this value of n may be even integer or odd integer. Suppose if you have n is equal to 1, you have only one term, that is sine theta only. If you have n is equal to 2, then there are two terms, that is sine theta plus sine of pi plus theta. If n is equal to 3, there are three terms, that is sine theta plus sine of pi plus theta plus sine of 2 plus 2 pi plus theta. And if n is equal to 4, there are 4 terms. If n is equal to 10, there are 10 terms. If n is equal to 11, there are n terms. So here n is generalized. Okay. So let us find out its value now. So again, let us write down the given expression. So here given expression is equal to sine theta plus sine of pi plus theta, okay, plus sine of, this is 2 pi plus theta plus, next what is the fourth term out here? It is sine 3 pi plus theta plus dot dot dot, it goes up to n terms. Okay. So now let us write down the formula for all these given terms. So first term is sine theta, it remains as it is. Okay. So next, what is sine pi plus theta? So what is the value for pi actually? Here pi is in terms of radian. You have to write it in terms of degrees. So pi is equal to 180 degrees. So let us write down the figure out here. Let us draw the figure. So let us draw the figure now. So here, this is your 0 degree. This is your 90 degree. This is 180. This is 270 degree. And 360 degree will coincide with 0 degree, right? But you can write it in terms of radian also. 0 degree in terms of radian is 0. 90 degree in terms of radian is pi by 2. 180 degree in terms of radian is pi. And 270 degree in terms of radian is, you know that this is 3 pi by 2. And 360 degree in terms of radian is what? It is 2 pi. As pi is equal to 180 degree. So now let us write down the formula for sine pi plus theta. So pi plus theta. So first of all, in which quadrant does this angle, that is pi plus theta, lie? In which quadrant does this angle pi plus theta lie? यो जुन चाहिँ pi plus theta छ, यो angle चाहिँ कुन चाहिँ quadrant मा पर्छ त्यो पहिला हामी चेक गर्छौं. ठीक छ? So pi plus theta, what is pi plus theta? This is your pi plus theta lies in the third quadrant. Okay. So in the third quadrant, you know that sine is negative, and since this is 180, you know that 180 degree is 90 degree into 2. So it is even multiple of 90. So if it is even multiple of 90, trigonometrical ratios do not change. I told you that one, isn't it? So it is sine theta. Is that understood now? Okay. Next. So let us write here plus. What is 2 pi plus theta? In which quadrant does this angle lie? First of all, you have to check in which quadrant does this angle 2 pi plus theta lie. यो जुन चाहिँ यहाँ angle 2 pi plus theta दिएको छ, यो कुन चाहिँ क्वाड्रन्टमा पर्छ पहिला हामी त्यो चेक गर्छौं. ठीक छ? 2 pi भने के भयो? 2 pi. This is your 1 pi. This is your 2 pi. 1 pi means half round. 2 pi means full round plus theta. In which quadrant does it lie? Now it lies in the first quadrant. And in the first quadrant, you know that all the trigonometrical ratios are positive. So here sine is positive. Okay. Now, does it change now? Sine. Will sine change to cos or not? So how can you check it? Since this is 2 pi, you know that this is 2 pi. 2 into pi means 180 degree. 2 into 80 degree means 90 degree into 2. So this is 90 degree into 4. So it is even multiple of 90. So I told you that if it is even multiple of 90, trigonometrical ratios do not change. So it is plus sine theta. So I think you have understood it. Okay. Next, what's about this sine 3 pi plus theta? So here also let us check in which quadrant does this angle 3 pi plus theta lie. Let us check it. So 1 pi means half round, 2 pi means full round, 3 pi means half round plus theta. It also lies in the third quadrant. This sine 3 pi plus theta also lies in the third quadrant. And in the third quadrant, you know that sine is always negative. So now what's about this 3 pi? Is 3 pi an even multiple of 90 degree or odd multiple of 90 degree? So how will you check it? So let us check it here now. Let us check it. So it is 3 pi, which is equal to 3 into what is pi? It is 180 degree. Which is equal to 3 into what is 180 degree? 2 into 90 degree. So it is 3 2s are 6 into 90 degree. So it is even multiple of 90, isn't it? So if it is even multiple of 90 degree, so sine remains as it is. Trigonometrical ratios do not change. So let us write here minus sine theta. So in this way, in this series, you can get alternate positive negative sign. Plus sine theta, minus sine theta, 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 and so on. Okay, it goes up to how many terms? To n terms. So I think you have understood it. Okay, so now the value of this series depends upon the value of n. So here n may be even integer or n may be odd integer. Suppose n is equal to 1. If we put n is equal to 1, I told you that there is only one term. That means what is this value? Sine theta. Okay. If we put n is equal to 3, how many terms are there? There are 3 terms. यदि तिमीले n is equal to 3 हाल्यो भने त्यहाँ कतिवटा टर्म्स हुन्छ? 3 टर्म्स हुन्छ. 3 टर्म्स भनेको from first term till third term. So it will be sine theta minus sine theta plus sine theta. Sine theta gets cancelled, you get only sine theta. Okay. So if n is equal to 5, there are 5 terms. It will be sine theta minus sine theta plus sine theta minus sine theta again plus sine theta will be there. If n is equal to 5. If n is equal to 5, how many terms are there? 5 terms. That is, it will be sine theta minus sine theta plus sine theta minus sine theta plus sine theta. So in that case also, you can cancel these two and you can cancel these two, you'll get only sine theta. That means if n is odd integer, if n is odd integer, then what is the value of the series? It is only sine theta. Is that clear? So let us write here, it is sine theta minus sine theta plus sine theta plus into minus minus sine theta plus dot 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 to how many terms? It is n terms, right? So it is n terms, right? So if n is odd integer, if n is positive odd integer, then what is the value of the series? Then value of the series, then value of the series is equal to only sine theta. So this is the answer. If n is positive odd integer, if you put n is equal to 1, you will get only sine theta. If n is equal to 3, there are 3 terms, sine theta minus sine theta plus sine theta. This first and second term will be cancelled, you get only sine theta. If n is equal to 5, you will have sine theta minus sine theta plus sine theta minus sine theta plus sine theta is also there because there are 5 terms. So you can cancel these first 2 terms and the next 2 terms. You will have only sine theta. Okay. If you have n is equal to 9 terms, then only in that case from first till 8 terms, all the terms will be cancelled and there remains only one term, that is the 9th term, which is equal to sine theta. So if n is positive odd integer, then what is the value of the series? It is sine theta. Suppose n is positive even integer. So what is even integer now? Suppose if you put n is equal to 2. If you put n is equal to 2, there are 2 terms only. There will be sine theta minus sine theta only. Both of them will be cancelled. You will get 0. If n is equal to 4, you will have sine theta minus sine theta plus sine theta minus sine theta only. There are 4 terms. All these terms will be cancelled. You will get 0. If n is equal to 6, suppose there are 6 terms. Sine theta minus sine theta plus sine theta minus sine theta. Again plus sine theta minus sine theta will be there. So in that case also all the 6 terms will be cancelled. Similarly, if n is equal to 10, all the terms will be cancelled, you will get 0. If n is equal to 100, all the terms will be cancelled, you will get 0. Okay. So if n is positive even integer, then value of the series will be equal to 0. So these are the 2 answers. So if n is positive integer, then value of the series is equal to sine theta. If n is positive even integer, then the value of the series will be equal to 0. Okay. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we will do the next question, that is question number 5. Number 1, if n is an integer, then prove that number 1, it is cos of n pi plus theta is equal to minus 1 whole to the power n cos theta. So here it is given that n is an integer. N may be even integer, n may be odd integer. You have to consider both even integer as well as odd integer for n. तो यहाँ के दिएको छ भन्दाखेरि n is an integer भन्ने दिएको छ. त integer भन्नाले हामी के बुझ्छौं? It may be even integer, it may be odd integer. So you have to consider both the cases, n as an even integer and n as an odd integer, right? So let us do this problem now. So let us write here, you have to prove LHS is equal to RHS. So LHS is equal to cos n pi plus theta. So how will you assume this odd integer? Let us assume that n is an odd integer, right? Let us assume first n as an even integer, okay? So first of all, let us assume this n as an even integer. So how can you assume the even integer? You know that even integer is a multiple of 2, isn't it? If a number is multiplied by 2, you will get always an even integer. त कुनै पनि इन्टिजरलाई तिमीले 2 ले मल्टिप्लाई गर्ने साथ त्यो के हुन्छ इभन इन्टिजर भइहाल्छ. So let us assume that let n be an even integer. Let n be an even integer. So let us assume n is equal to twice k. So what is k here? K is any integer where k is any integer. So any integer means it may be even integer, it may be odd integer. If that even integer or odd integer is multiplied by 2, that will always be an even integer. कुनै एउटा integer छ त्यो odd पनि हुन सक्छ even पनि हुन सक्छ. जस्तै यहाँ हामीले के सपोज गर्यौं त यदि त्यो इन्टिजरलाई 2 ले मल्टिप्लाई गर्ने बित्तिकै के हुन्छ that is always an even integer. Is that clear? So always the even integer you can take it as n is equal to 2k where k is any integer. त जहिले पनि तिमीहरुले कुनै एउटा even integer सपोज गर्नु परे 2k सपोज गर्ने अनि त्यहाँ के लेख्छौ where k is any integer. It may be even or it may be odd integer. If that integer is multiplied by twice or 2, you will get an even integer. So let n is equal to 2k be an even integer. So in this case where k is any integer. Okay. So now this left hand side becomes cos, what is n here? It is 2k pi plus theta. So which is equal to, what is this formula now? Now you should know this formula, that is cos, it is 360 degree, isn't it? 2 pi means 360 degree into k plus theta. So I told you about this angle. In which quadrant does this angle lie? In which quadrant does this angle lie now? Where k is any integer. Suppose if we put k is equal to 1, 360 into 1 means full round plus theta always lies in the first quadrant. You know that, isn't it? You can draw the figure also. Suppose this is the figure. Okay, this is 0 degree. This is 90 degree. This is 180. This is your 270 degree and 360 degree will coincide with 0. You know that this is the first quadrant, this is second, this is third, and this is fourth. You know that, isn't it? Now suppose if you put k is equal to 1, this is 360 into 1 plus theta. 360 into 1 means full round plus theta lies in the first quadrant. What is 360 into 2? 360 into 2 means 1 round, 2 round plus theta lies in the first quadrant. Again, what is 360 into 3? 3 round plus theta always lies in the first quadrant. Whatever may be the value for k here, 360 into k plus theta always lies in the first quadrant. And in the first quadrant, cos is always positive. Okay. So which is equal to cos, what is 360 degree? 90 degree into 4k plus theta, which is equal to, also you know that this 4k is an even integer. If an integer is multiplied by 4, that is also an even integer. So it is 90 degree into even integer. So 90 degree into even integer is there. So trigonometrical ratios do not change, which is equal to cos theta. It lies in the first quadrant. So cos is positive in the first quadrant, and this is 90 degree into 4k. It is even multiple of 90. So trigonometrical ratios do not change. It remains as it is. So it is cos theta. Is that clear? But you have to write down the answer in terms of -1 whole to the power n cos theta. Okay. So before cos theta there is positive. So you know that if you write minus 1 whole to the power even integer, if you write minus 1 whole to the power even integer means it may be 2, it may be 4, it may be 5, even integer means it may be 2, it may be 4, it may be 6, it may be 8, 10 and so on. That is your even integer. If this minus 1 is multiplied even number of times, then it will be plus 1, isn't it? Then it will be plus 1. You know that, isn't it? If it is minus 1 whole square, minus 1 into minus 1 plus 1. If it is 4, minus 1 into minus 1 into minus 1 into minus 1, this minus sign is multiplied even number of times, it is also plus 1 and so on. Okay? But if it is odd integer, then what can you write? Minus 1. So minus 1 whole to the power odd integer is minus 1. Suppose if you put odd integer as 1, what is minus 1 whole to the power 1? That is only minus 1, so it is minus 1. What is minus 1 whole cube? Minus 1 is multiplied thrice. That is minus into minus into minus. 3 minus sign are there. So minus into plus, plus into minus is minus. If you put odd integer as 5, it will be negative 1. If it is n is equal to 7, it will be minus 1 and so on. If it is odd integer, minus 1 whole to the power odd integer is always minus 1. Is that clear? So here minus 1 whole to the power even integer is plus 1. And minus 1 whole to the power odd integer is minus 1. You know that, isn't it? So here cos theta a positive, sir. So instead of that positive number, you can write minus 1 whole to the power this 2k. You know that 2k is even integer. If an integer is multiplied by 2, it is always an even integer. And you know that minus 1 whole to the power even integer is always plus 1. So instead of this coefficient of cos theta, that is plus 1, we have written here minus 1 whole to the power 2k. Then you can write cos theta. So which is equal to, this is minus 1 whole to the power, what is 2k out here? It is n. So it is cos theta. So we have proved it. So if n is an even integer, we have proved that this LHS is equal to RHS. So we have got minus 1 whole to the power n cos theta. So I think you have understood it. Now let us assume this n as an odd integer. Okay? So let us assume n as an odd integer. Now again, LHS is equal to cos n pi plus theta. Now in this case, let us assume n as an odd integer. Let n be an odd integer. Let n be an odd integer. So how can you assume the odd integer? हामीले odd integer चाहिँ कसरी सपोज गर्छौं त भन्दाखेरि let n is equal to 2k. If you write 2k, it is an even integer. You may write minus 1 or plus 1. If from an even integer 1 is subtracted, if from an even integer 1 is subtracted, then that will be an odd integer. Or if 1 is added to the even integer, that is also an odd integer. Okay, you may write minus 1 or plus 1. So let us write here 2k plus 1. 2k plus 1, right? You know that 2k is an even integer. If an integer is multiplied by 2, it will be an even integer. So यो 2k के भयो? Even integer. Even integer मा plus 1 गर्ने बित्तिकै के भयो त्यो? Odd integer. But here you have to write where k is any integer. Where k is any integer. I think you have understood it. If a number or an integer is multiplied by twice, it will be an even integer. If we add 1 to this even integer, it will be an odd integer. So odd integer can be assumed as n is equal to 2k plus 1. I think you have understood it. So let us write down left hand side now. So it is LHS is equal to cos. Now within second bracket, let us put the value for n. What is n here? It is 2k plus 1 into pi plus theta. Okay, so which is equal to cos within second bracket. Let us multiply them. 2k into pi, 2k pi plus 1 into pi, pi plus theta. So now how will you evaluate this expression now? अब हामी यो expressions को formula चाहिँ के हुन्छ? So how can you evaluate this expression now? So now in this case we have cos, again you can write it in terms of degrees. Pi is 180 degree, 2 into 180 degree is 360 degree, multiply by k plus, you can write it within bracket, pi plus theta. Second bracket is closed. Okay, now here we have, or you may write here cos, what is 360 degree, 90 degree into 4k plus, this is your pi plus theta. Okay, so now here within bracket there is pi plus theta. Let us take it as theta. यहाँ ब्रैकेट भित्र हामीले के देख्यौं? पाई प्लस थीटा. पाई प्लस थीटालाई हामी एकछिनको लागि थीटा सम्झ्यौं. यो थीटा भयो भने के हुन्छ? 90 डिग्री into 4k plus theta भइगयो. यो आयो कि हैन? Cos 90 degree into 4k plus theta is equal to cos theta. You know that, isn't it? But in this case, what is the value for theta here? It is pi plus theta. So instead of theta here, there is pi plus theta. The formula is same, isn't it? Whatever may be the angle here, let us take it as theta. This 90 degree into 4k plus theta always lies in the first quadrant. And in the first quadrant, cos is always positive. And it is even multiple of 90. So cos remains as it is. So let us take it as theta. What is the formula? Cos theta. But here, what is the value for theta? It is pi plus theta. It is pi plus theta. So I think you have understood it. Okay. So now what is the formula for cos 180 plus theta? Now it is 180 degree plus theta. 180 degree plus theta, where does the angle lie? It lies in the third quadrant. And in the third quadrant, cos is always negative. Okay. And this pi is 180 degree. 180 degree means 90 degree into 2, which is even multiple of 90. So cos remains as it is, or trigonometrical ratios do not change. So it is minus cos theta. So I think you have understood it. Okay. But you have to write down the answer in terms of minus 1 whole to the power n cos theta. Okay. So what is the coefficient of cos theta here? Actually it is minus 1. If there is only minus, so it is understood that there is minus 1. Okay. So here you can write down as minus 1 whole to the power odd integer is minus 1. You know that, isn't it? What is odd integer here? 2k plus 1. So it is minus 1 whole to the power 2k plus 1. And you know that 2k plus 1 is an odd integer. So you can write minus 1 whole to the power odd integer, which is equal to minus 1. Understood? So into, what will you write here? Cos theta. Now I think you have understood it. So which is equal to minus 1 whole to the power. Now what is the value for 2k plus 1? What is the value for 2k plus 1? It is n. Then you can write cos theta. So we have proved it. Okay. So here you can write hence cos n pi plus theta is equal to minus 1 whole to the power n into cos theta. So it is done, proved. Okay. So this question is very, very important. You can mark it. So I think you have understood it. You can copy it. Now we'll do the next question. So now we'll do the next question, that is 5 number 2. So this is same type of question as we have done in the previous problem. So question number 5, if n is an integer, it may be even integer, it may be odd integer, you have to prove that number 2. Tan of within second bracket n pi by 2 plus minus 1 whole to the power n into pi by 4 is equal to 1. You have to prove that LHS is equal to RHS. And these number 3 and number 4 will be a homework. Okay, it is same as problem number 1. So homework is your number 3, that is sine within second bracket n pi plus minus 1 whole to the power n pi by 6 is equal to, you have to prove half. And in number 4 you have to prove that tan of within bracket n pi plus alpha is equal to tan alpha. Okay, so these two you can use the same method as we have done in problem number 5 number 1. Okay, so we have to assume both n as an even integer as well as odd integer, right? So let us do this question number 2 here, right? So let us prove this LHS is equal to 1. So let us write down left hand side here. So LHS is equal to tan within second bracket n pi by 2 plus minus 1 whole to the power n into pi by 4. So let us assume n as an even integer. Let n be an even integer. Here also you have to assume n as an even integer as well as odd integer. Okay, so how can you assume n as an even integer? I already told you that let it can be assumed as n is equal to 2k. If a number, whether it is odd integer or even integer, if it is multiplied by 2, it will always be an even integer. You know that, isn't it? So where you have to write where k is any integer. Is that clear? So let us put the value for n is equal to 2k in left hand side. So now this left hand side now becomes tan within second bracket. What is n here? It is 2k by pi by 2 plus minus 1 whole to the power 2k into pi by 4, right? So which is equal to tan, now within bracket, here you can cancel this 2, so it is k pi, right? Then plus, what is minus 1 whole to the power 2k? And you know that 2k is an even integer. If minus 1 is multiplied even number of times, it will be plus 1. You know that, isn't it? Yadi yo minus 1 say even number of times multiply by say that will be plus 1. Take sir? So it will be minus 1 whole to the power even integer is always plus 1. So it is only pi by 4. Right? So which is equal to tan. What is 180 degree? This pi is 180 degree. It can be written as 90 degree into 2k plus pi by 4. So in which quadrant does it lie? Can you tell me in which quadrant does it lie? So it is 90 degree into 2 is 180 degree, that is the value for pi, and k is there, plus pi by 4. Right? So let us draw the figure again here. Actually you don't have to draw the figure if you understand the problem. If you understand the problem, you don't have to draw the figure, right? So this is your 0 degree, this is your 90 degree, this is your 180, this is your 270, and this is your 360 degree. It will coincide with 0 degree. That means in terms of radian it is 0, in terms of radian it is pi by 2, in terms of radian it is pi, in terms of radian this 270 degree is 3 pi by 2, in terms of radian 360 degree is 2 pi. You know that, isn't it? Now let us check in which quadrant does this angle lie. 90 degree into 2k plus pi by 4, or in which quadrant does this lie? K pi plus pi by 4. Here k is a general integer, k may be any integer. If you put k is equal to 1, suppose k is equal to 1 हालेर, k is equal to 1 हाल्दा pi plus pi by 4, isn't it? What is pi plus pi by 4? Pi plus pi by 4. It lies in the third quadrant. Okay? And in the third quadrant, tan is always positive. You know that. Isn't it? Again, if you put k is equal to 2 pi, k is equal to 2. If you put k as an even integer, suppose k is equal to 2, it is 2 pi. What is 2 pi here? This is 1 pi, 2 pi plus pi by 4 lies in the first quadrant. So if k is equal to 2, then 2 pi plus pi by 4 lies in the first quadrant. Suppose k is equal to 3. So it will be 3 pi plus pi by 4. Where does it lie? 3 pi means 1 pi, 2 pi, 3 pi plus theta also lies in the third quadrant. Suppose if k is equal to 4, it is 4 pi plus pi by 4. What is 4 pi? What is 4 pi? 1 pi, 2 pi, 3 pi, 4 pi plus pi by 4 lies in the first quadrant. Is that clear? That means this angle, that is k pi plus pi by 4, which is equivalent to 90 degree into 2k plus pi by 4, will lie in the third quadrant as well as in the first quadrant. Okay? This angle, that is k pi plus pi by 4, or it may be 90 degree into 2k plus pi by 4, may lie in the third quadrant or in the fourth quadrant. And both in the third quadrant and in the first quadrant, tan is always positive. You know that, isn't it? So it is positive sign. So positive sign, usually we don't write it. Okay? Again, this 90 degree into 2k is even multiple of 90. 2k bhaneko ke bhayo? Even integer, even multiple of 90. So if it is even multiple of 90, trigonometrical ratios do not change. So it is tan pi by 4. So which is equal to, what is this value? This is 1. Proved. So I think you have understood it. Okay? Is there any problem? I think there is no problem. So we can revise it at home. Okay? Now, so actually you don't have to draw the figure. Just try to understand it. Okay? So I am drawing the figure in order to explain you. Okay? I think you have understood that figure. Okay? Now in this case we had assumed n as an even integer. Let us assume n as an odd integer. Now let n be an odd integer. Let n be an odd integer. So how can you assume the odd integer? I already told you that you may write n is equal to 2k plus 1 or 2k minus 1. So I suggest you to write down plus 1 because it will be easier for you to simplify if you write plus 1. Okay? So let us write n is equal to 2k plus 1 as an odd integer, where k is any integer. It may be odd integer, it may be even integer. If an odd integer or even integer is multiplied by 2, and if it is added, if 1 is added, if an integer is multiplied by 2, if an integer, that means it may be odd integer, it may be even integer. If even integer or odd integer is multiplied by 2 and 1 is added to it, it will be an odd integer. So in this case, k is any integer. It may be even integer, it may be odd integer. So let us put the value on the left hand side. Okay? So now LHS now becomes, what is LHS now? Tan within second bracket. Let us put the value for n. What is the value for n here? It is 2k plus 1. Then you can write pi divided by 2. Is that clear? Then plus minus 1 whole to the power. What is n here? We have to put the value for n. Here n is 2k plus 1. Here n is 2k plus 1. Then you can write pi by 4. Then you can write pi by 4. Okay? So which is equal to tan, let us simplify it further. It is 2k pi. Let us multiply them. 2k pi plus 1 into pi pi divided by 2. Alright. Then next, what is minus 1 whole to the power 2k plus 1? Here 2k plus 1 is an odd integer. So minus 1 is multiplied odd number of times. So it will be minus. And this is pi by 4. Is that clear? Tan, let us separate the term here. We can separate the term 2k pi by 2 plus pi by 2 minus pi by 4. So let us put it within bracket. Pi by 2 minus pi by 4 is kept within bracket. So here 2 gets cancels, which is equal to tan within second bracket k pi plus, what's the LCM here? 2 and 4. LCM is 4. 4 is divided by 2, that is 2. 2 is multiplied by pi. 2 pi minus, now 4 is divided by 4, that is 1. 1 into pi is pi. 1 into pi is what? It is pi. Right? So which is equal to tan. So it is k pi plus pi by 4. It is same as previous one, isn't it? That is tan k pi plus pi by 4. So we have got the same result out here also. So this can be written as tan, how do you write pi? 90 degree into 2k plus pi by 4. I think you have understood it. It is same as this previous one, tan k pi plus pi by 4. And we have written here, what is pi? 90 degree into 2k plus pi by 4. Now it is, now this always lies, this 90 degree into 2k plus pi by 4. Where k is any integer. It may lie, this angle may lie in the first quadrant or in the third quadrant. And in both the quadrants, in the first quadrant and in the third quadrant, tan is always positive. So which is equal to, so positive sign usually we don't write it. And since this is even multiple of 90, 2k is even integer. So it is even multiple of 90. So trigonometrical ratios do not change. It remains as it is, which is equal to tan pi by 4. What is tan pi by 4? It is also 1. Proved. I think I have understood it. So we can write here hence tan within second bracket. What is the question given out there? This is the question. N pi by 2. N pi by 2 plus minus 1 whole to the power n into pi by 4, which is equal to 1. So it is done. That means it is proved. So hence this left hand side is equal to 1. That is tan of within second bracket n pi by 2 plus minus 1 whole to the power n into pi by 4 is equal to 1. So it is proved. So we have assumed both these values of n as an even integer or n as an odd integer. Okay, so here we have assumed n as an even integer. Here we have assumed n as an odd integer. In both the cases we have got the value, that is left hand side is equal to 1. So this is the answer. So this question is also very important. So you can copy it. So similarly you can do this number 3 and 4. It is same as question number 1. So I think you have understood it. So you can copy it. So this much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं यो घरमा राम्रोसँग रिभिजन गर्नु, यो दुईटा पनि होमवर्क गर्नु. So in the next online class we will do more problems on this chapter, that is trigonometrical ratios of associated angles. So this much is for today.